Statement is that two particles, 1 and 2, they are moving with constant velocities v1 and v2. At the initial moment, their radius vectors are equal to r1 and r2. How must these four vectors be interrelated for the particles to collide? So we have two particles, 1 and 2. So this is particle 1, this is particle 2, and they have initial position vectors of r1 and r2 given in this diagram, and they are moving with velocities v1 and v2, which is also shown in the diagram. And the question is asking us to find out the relation between these four vectors, which is r1, r2, v1 and v2. So let us assume that the particles collide at, let's say, this point x, and let's say they collide after time t. So t is another variable. So collision occurs after time t. So from the figure we can write an equation which would be something like r1, which is the initial position vector for particle 1, and we add v1 multiplied with time t. So r1 is the vector from this origin. Let's say this is the origin. So for the first particle, its initial position vector is given by r1, and then it travels from this point 1 to point x in time t with a velocity vector of v1. So we get r1 plus v1t, and this is the final position of x from the origin O, which is traveled by the particle 1, and this is equal to vector r2 plus v2 by t. So this is the position vector of x, which is given by the the path traveled by particle 2. So now if we rearrange the variables in this equation, we get r1 minus r2 will give us v2 minus v1 multiplied by this scalar quantity t, and this equation tells us that the relative velocity v2 minus v1 will have the same direction as the vector r1 minus r2. So the vector r1 minus r2 will be given by this line here. So this is r1 minus r2. So the vector v2 minus v1, if the particles are to collide, then v2 minus v1 will also have the same direction as the vector r1 minus r2, but there is going to be a factor of we have to multiply it with a factor of t, because the magnitudes are not going to be the same for both of these vectors, r1 minus r2 and v2 minus v1. So this is where t comes into picture. We can write the variable t as r1 minus r2, the magnitude of it, and divide it by the magnitude of vector v2 minus v1. So we get a value of t. We can substitute this value of t in our previous equation to get r1 minus r2 is equal to v2 minus v1, and we multiply it with modulus of r1 minus r2 divided by modulus of v2 minus v1 rearranging this equation, we get R1 minus R2 divided by the modulus of R1 minus R2 should be equal to V2 minus V1 divided by the modulus of V2 minus V1. So this is our final answer. If these two particles are to collide, then this is the relationship that these four vectors must have so that these particles can collide. So yeah, this is it for today. Thank you for watching. Bye.